what is the property of the transformer core, and how transformer cores are uh, constructed using the CRGOS steel sheet, right? We have also noted that the presence of CRGO laminations in the transformer core reduces both the eddy current loss as well as the hysteresis loss, right? So now we have concluded that if we cut the cross section of the CRGO sheet or laminated sheets in this way, at an angle of 43 and 47 degree at the two corners, then the least magnetizing current will be required by the transformers, uh, and it will provide the better magnetic property, right? So in this way, single seat, all these seats are basically jointed. Uh, all the layers of the core are basically joined with each other, right? So this is a single layer. So n number of layers, depending upon the requirement of the transformer, n number of laminated sheets can be combined and stacked together to form the entire cross section of the transformer core. So finally, at last we will draw this in which you can visualize the fact that how the transformer core is basically prepared. Right. So by combining the multiple number of laminated sheets, we can form the transformer core. So suppose this angle is 43 degree and this angle is your 47 degree. Right. So this figure basically represents the laminated sheets cut at an angle of 47 degree and 43 degree on the two ends of two ends, right? And all these are assembled to form a layer of the core laminations, right? Now, uh, uh, here in the figure, you can see that we have the rectangular cross section of the limbs, right? So a small core type transformers are basically made up of rectangular section core limbs, right? A small transformers जो होते हैं उसमें rectangular section of core limbs are used, right? But in case of large transformers, uh, the minimum cross section of the core should be desired, or you can say that in all the transformer for economical regions, we should have the least core material as well as the conductor required for the winding purposes should be minimum, right? So economical use of core material basically requires that the cross section of the core should be circular in nature, because you know that a circular cross section will give you the minimum peripheral length for a particular area, right? So for larger transformers, the core cross section is basically circular, right? Because it will give you the least peripheral length, because this type of circular core limb will give you least peripheral area, right? So with this least area, the length of the mean turns of the conductor winding required will be less. So this will reduce the cost of the copper winding or wire required for the winding purpose in the transformer. So due to this circular cross section, your conductor turns or length, you can say, required will be less, and hence the entire system will become economical. ठीक है? now the question is how to make the cross sectional area circular. मीन्स ये दो लिम्ब जो है सपोज L1 एंड L2, इसके क्रॉस सेक्शन को कैसे हम लोग सर्कुलर बनाए। अभी तक तो हम लोगों ने ये डिस्कस किया कि हम लोग इस क्रॉस सेक्शन का जो है सो सीट कट कर लेंगे फ्रॉम द अवेलेबल laminated CRGO sheet, and by combining all these things in proper way, proper way means the grains are oriented in the direction of flux, useful flux in the transformer, so we can form the transformer core. But now we came to the conclusion that we have to make the circular core limbs, that is L1 and L2 cross section should be circular in nature. So to make the limb cross sectional area circular, the width of each lamination should be made variable, right, which will be very uneconomical in nature. तो इसमें तुम ऐसे कंसीडर कर सकते हो कि अगर तुमको सर्कुलर लिम्ब, ये एक लिम्ब है मान लो सपोज L1, ये बनाना है, so you can combine the laminated sheets of different length in this form to form a circular cross section of the core limb of the transformer. ये एक सपोज जो है ये रिप्रेजेंट कर रहा है एक लेमिनेशन को, एक लेमिनेटेड सीट को, ठीक है। तो इस तरह से अगर हम लोग कट करते हैं इस सीट से कोई मटेरियल डिफरेंट क्रॉस सेक्शन लेंथ का, then that will be completely uneconomical system, right, because you will require n number of laminated sheets having different length, that is length will be variable. So a compromise has to be done in order to form the core section, which you can think in this way. Suppose this is the outer cross section of the core. So if suppose we cut the cross section in this way, then another one suppose sorry, ये हो गया, फिर इस तरह से, फिर suppose you cut in this way, sorry. So in this way you can form the circular cross section of the transformer core. And so on, right? So here this suppose figure A, this is figure A and this is figure B. So this figure A represents the cross section of the core limb using laminations of variable widths, with laminations of variable width. And this figure B represents the cross section of the core limb using laminations of only you can say 3 width, 1 2 3, 3 different width, with laminations of 3 different width, ठीक है। So this is the process by which you can develop the transformer core, right? तो ये basic है, basic चीज while thinking about the construction of the transformers. So any confusion in this part? So if there is no confusion or any question, then now we will come back to the equivalent circuit and phasor diagram part of the transformer, जो कि हम लोगों ने पहले पढ़ा था at no load condition. So we have earlier considered a transformer operating at no load condition, and that transformer was ideal. That is, we have ignored the effect of leakage flux in that transformer. So now if we talk about any practical transformer, then here we will see the transformer phasor diagram, phasor diagram, phasor diagrams, मीन्स ये हम लोग प्रैक्टिकल ट्रांसफार्मर के बारे में बात करेंगे, प्रैक्टिकल ट्रांसफार्मर्स at different power factor loads, right? Earlier we have assumed that the transformer is operating at no load condition. We have also seen one condition when we have ignored the impact of the secondary winding resistance as well as leakage reactance, and then we have drawn the phasor diagram as well as the equivalent circuit of the transformer, right? So here we will consider all the aspects which are possible in case of a single phase transformer. So let us draw first of all the block diagram, for which we will draw the equivalent phasor diagram as well as the equivalent circuit diagram. So let us consider again a rectangular cross section of the transformer core, right? आवाज आ रही है ना? V1. Okay. Suppose these are the two terminals on this side, A and B, and again you have a second winding at the output terminal, and the load is connected across the output terminal with the help of a switch. Suppose this is the switch which is initially in the open state condition, and this is your load. Suppose these are the two terminals which is C and D, right? So here we have already discussed that if we connect this switch S to close position, then the current will be I1, which will have two components, the no load component as well as the demagnetizing component, compensating current जो I1 dashed होता है. Suppose this I1 has I0 plus I1 dashed. We have already discussed about the significance of this I1 dashed, right? So when this switch is suppose closed, then a current I2 starts flowing from the terminal C towards terminal D, and again here suppose you have E1 as the induced EMF and E2 is the induced EMF across the secondary coil, and then this is your flux. Main flux is phi, and there will be some leakage flux also in both the primary winding as well as the secondary winding. Leakage flux presence will be also there due to the different non-magnetic materials. You can think about either non-magnetic material, that is air, or transformer oil, which is present in the transformer tank, right? So suppose the leakage flux on the primary side is phi L1, and on the secondary side it is phi L2, right? So here we have to draw the phasor diagram of this complete system. Here we are considering the winding resistance also, leakage flux, due to which leakage reactance will be there, right? So first of all, let me rewind something or tell me something about again the leakage flux in the system. So the you know that when the current suppose I1 is flowing through the primary coil or winding through this point A towards B, then it means that your point A is at higher magnetic potential than point B. So this magnetic potential difference will cause the mutual flux as well as the uh, primary leakage flux, right? ये करंट जब फ्लो करेगा प्राइमरी वाइंडिंग में I1, then there will be two component of the flux. First one will be your main flux, that is phi and phi L1, right? Similarly, when the current I2 will flow through the secondary winding, it will also produce some leakage flux, that is phi L2. ठीक है? Now the mutual flux phi exists entirely in the ferromagnetic transformer core, right? ये जो phi है, main flux और core flux, mutual flux जिसको बोलते हैं, it basically exists in the transformer core, which is made up of ferromagnetic material, right? Therefore, it involves the hysteresis loop. So your phi is involved in the hysteresis loop, right? But phi L1, suppose the leakage flux produced by the secondary coil or winding, phi L1 exists largely in the air, right? Although phi L1 will also pass through some of the iron core, it will also pass through. But the reluctance offered to phi L1 is mainly due to the air, right? Reluctance offered is mainly air. It means that it does not involve in the hysteresis loop, right? And therefore it can be taken to be in phase with the no load current, that is I0, right? Which is basically producing it. Now the effect of this leakage flux is considered by a leakage reactance in both the phasor diagram as well as in the circuit diagram of the transformer, because ultimately what is happening, due to the leakage flux, the magnitude or strength of the mutual flux is basically reducing. अगर मान लो कि लीकेज जीरो होता, then obviously entire flux developed due to the no load current ये link करता through the secondary coil. But now phi is basically your core flux or mutual flux, which is obtained after subtracting the leakage flux phi L1 from the total flux generated by the current I0. So the magnitude or strength of the transformer mutual flux has reduced because of the presence of leakage flux. तो उस reduced magnitude की वजह से क्या होगा? There will be lesser rate of change of flux in both the primary and the secondary winding. So if rate of change of flux will reduce, then E1 and E2, if rate of change of flux is reduced, this will employ E1 to reduce and also E2 to reduce. तो अब जैसे कि E1 रिड्यूस कर गया, E2 रिड्यूस कर गया, इसको कैसे हम लोग किसी सर्किट डायग्राम में या फेजर डायग्राम में रिप्रेजेंट करेंगे? बाय सम वोल्टेज ड्रॉप, ठीक है? तो इसके इफेक्ट को हम लोग इंडक्टेंस से और रिएक्टेंस से रिप्रेजेंट कर सकते हैं, बिकॉज you know that there will be voltage drop across the reactor present in any electrical circuit, right? So this is about the significance and concept of leakage flux in the transformer. So now come back to this figure, block diagram of the transformer, loaded transformer. So when the switch S is closed, then I2 will start flowing through this secondary circuit, right? I2 flow karega secondary circuit mein. So first of all, let us consider that this load power factor, load is of lagging power factor load is there. Lagging power factor load is connected across the secondary winding. So we have to draw the phasor diagram in this condition. So the basic part of the phasor diagram will be common here. On the reference axis, again we will take the mutual flux which links both the winding. Then you know that E1 and E2 will lag the flux by 90 degree. right? Now, since here we are assuming the some resistance as well as leakage reactance effect also. Therefore, earlier what we have done here, we have just represented it by V1. ये V1 से कर देते थे represent, but now we cannot do that because V1 will be different as compared to E1 due to the presence of winding resistance as well as leakage reactance on the primary circuit as well as the secondary circuit. So let us consider this voltage as V1 dashed, which will be basically equal to V1 dashed is basically the voltage across the output terminals across the primary coil. So V1 dashed is basically equal to minus E1, right? So this is your V1 dashed, which is equal to minus E1, right? Now we have already discussed about the magnetizing current, that is Im, which is in phase with the mutual flux, and the loss component of the no load current, which is Ic. So the combination of these two is giving us the total no load current, right? Now the second step is that we have connected a load across the secondary winding. So there will be a voltage across the load. Let us consider this voltage as V2. लोड टर्मिनल के क्रॉस जो वोल्टेज है उसको मान लिए हम लोग V2 है. So if load is lagging in nature, it means the current I2 will lag V2 by some angle. करंट जो है वो लैग करता है, लैगिंग पावर फैक्टर के केस में वोल्टेज से लैग करता है. तो सपोज this is your V2, right? Now, if we take this position of V2, then current I2 will be lagging V2 by some angle, suppose theta 2 angle. ठीक है. अब बताओ कि अब क्या करना होगा. As we have considered the winding resistance, therefore definitely there will be some resistance and also the reactance due to the effect of leakage flux. तो यहाँ पे इस टर्मिनल के क्रॉस तुम्हारा V2 है और यहाँ पे E2 है, right? So apply KVL. So if you apply KVL, then you will get E2, and this is the direction of current we have considered, I2. E2 minus I2 R2, if this is R2 and this is X2. I2 E2 minus I2 R2 minus J I2 X2 will be equal to V2, right? That is E2 will be basically equal to V2 plus I2 R2 plus J X2. तो ये V2 है तुम्हारा, इसमें क्या ऐड करना होगा I2 R2. So what will be the direction of I2 R2? बताओ I2 R2 का क्या डायरेक्शन होगा? बोलो. I2 R2 should be added to V2 R2. Actually, we have to obtain this E2, that is the induced EMF across the secondary winding. So V2 is known to us, I2 इससे lag कर रहा है theta angle से. So I2 R2 will be just parallel to the current. There is no phase difference. So this is suppose I2 R2, this part. Now there is a second term which is JI2. So J means this is in plus 90 degree operator, right? इसका मतलब क्या होता है? J को हम लोग कैसे लिख सकते हैं? किसका है ये? सुचेतन ससीस. ठीक ठीक. 130. ओके. सो इसको जो है J को हम लोग क्या लिख सकते हैं? cos 90 डिग्री प्लस J sin 90 डिग्री. इसका cos 90 डिग्री का वैल्यू 0 प्लस J sin 90 डिग्री का वैल्यू 1. So this will be your same thing. So there is a 90 degree phase. There should be 90 degree phase difference and also leading in nature. तो किधर होगा बताओ, इधर होगा या इधर होगा, डाउनवर्ड और अपवर्ड? हेलो, आवाज नहीं आ रही है क्या?
सर डाउनवर्ड।
राइट, इट विल बी डाउनवर्ड, तब तो लीड करेगा इससे, अदरवाइज इट विल लैग। तो ये जो तुम्हारा हुआ ये हो गया Ji2x2, तो दिस वोल्टेज इज योर E2, E2 यहाँ। So from phasor diagram you can say that E2 is equal to this V2 plus I2R2 plus J I2X2. This angle is 90 degree, right? So this is the phasor diagram of the secondary circuit. Now come back to the primary circuit. So you know that what was the effect of the current I2? The effect of I2 was to draw the additional current I1 dashed from the primary circuit or from the supply, right? It means I1 dashed will be just opposite in phase and equal in magnitude to I2. ये मान लो I1 dashed है, and the combination or phasor summation of I1 dashed and this I naught, that is no load current, is giving you the total current, total primary current drawn by the drawn from the supply, right? So now you try to complete the phasor diagram for the primary circuit also. So again you try to write the KVL first. So if we write the KVL in the primary circuit, so you think about this part only and try to draw the circuit of this part. So here you have V1, then there will be some winding resistance X1, sorry R1, then there will be reactance, leakage reactance X1, and here you have V1 dashed, right? So now I1 is flowing in this direction, so the KVL will be V1 minus I1 R1 minus J I1 X1 will be equal to V1 dashed. That is V1 is equal to V1 dashed plus I1 R1 plus J I1 X1. So here you have V1 dashed at this point, right? So you have to add I1 R1. So I1 is in this direction. So again I1 R1 will be parallel to I1. So this is your I1 R1. And then you have a J operator, that is plus 90 degree. That is it will lead the I1 R1 by plus 90 degree or 90 degree. So J I1 X1 will be in this direction. J I1 X1. This is again 90 degree. And this resultant will give you the source voltage V1. ठीक है, तो V1 और I1 के बीच का एंगल कुछ मान लो, सपोज दिस इज θ1. V1 और I नॉट और नो लोड करंट के बीच के एंगल को हम लोग पहले शायद θ0 बोल रहे थे, राइट? θ0. So this is the phasor diagram of a transformer operating at lagging power factor load, right? Another thing is that if you want to show the presence of leakage flux also in this phasor diagram, so can you tell me what will be the direction of the secondary leakage flux? Secondary leakage flux जो phi L2 है सपोज, ये किधर होगा? तो इसके लिए तुमको सोचना होगा इस तरह से कि phi L2 why it is produced. So this is produced because of the secondary current I2. So if we so phi L2 will be basically in phase with I2, right? अब ये अगर phi L2 है, so what will be the direction of the EMF induced because phi L2, suppose E phi L2 इसको represent करते हैं, so EMF will lag the flux by 90 degrees, so this will be your E phi L2 or EX2, whatever you represent to the EMF developed due to leakage flux. So this is your effect of leakage flux. Similarly, you can think about the primary leakage flux also. If phi L1 is the leakage flux, तो वो किसकी वजह से develop हो रहा है? So it is getting developed because of I1. So it will the EMF induced due to the primary leakage flux will lag the current I1 by 90 degree, right? So this is the complete phasor diagram. If you have any question, you can ask. For lagging power factor load, this is for lagging power factor load. ठीक है?
Yes, sir.
Okay. Now you try to draw the phasor diagram. Phasor diagram of transformer, of the same transformer at leading power factor लोड. ये ट्राई करो कैसा होगा, खुद से बनाओ. उसके बाद मैं 2 मिनट का समय दे रहा हूँ, बनाओ खुद से और वेरीफाई करना जब हम बनाएंगे तो सही बनाए हो कि गलत बनाए हो. जो बेसिक पार्ट है वो तो पहले ड्रॉ करना पड़ेगा किसी भी केस में, किसी भी पावर फैक्टर पे बनाओ तो. सपोज here you will have flux, main flux, that is mutual flux phi. Then again in this direction you will have E1 and E2. The magnitude of E1 and E2 basically depends upon the number of turns. तो वो किसका ज्यादा है किसका कम है वो तुमको उस हिसाब से बनाना पड़ेगा. अगर मान लो कहीं बोला गया है कि N1 is greater than N2 तो E1 का मैग्नीट्यूड इसमें फेजर डायग्राम में तुमको बड़ा दिखाना होगा, E2 का कम दिखाना पड़ेगा. तो दैट एडजस्टमेंट यू हैव टू डू. ठीक है? तो इसमें क्या था? हाँ, फिर इधर तुम्हारा V1 डैश्ड है, वो भी तुम्हारा कॉमन ही है. मैग्नीट्यूड विल बी सेम. इसको समझना कि ये और ये जो है दोनों सेम मैग्नीट्यूड का है. E1 के मैग्नीट्यूड के बराबर है V1 डैश्ड बट अपोजिट इन डायरेक्शन, राइट? नाउ V2 है सपोज यहाँ पे, तो लीडिंग पावर फैक्टर के केस में क्या होता है ये बताओ. इफ द लोड इज लीडिंग इन नेचर then the current I2 will lead the voltage V2, terminal voltage V2 by some angle theta 2. अब दो पॉसिबिलिटी है, एक तो कि तुम्हारा करंट इधर ही कहीं आ जाए, एक ये भी पॉसिबिलिटी है कि इधर भी कहीं आ जाए. तो दोनों के लिए ट्राई करो. मान लो कि पहले हम लोग इधर के लिए करते हैं. ये है सपोज I2 एंड दिस एंगल इज योर थीटा 2, राइट? तो इधर वाला पार्ट भी ये कंप्लीट कर लेते हैं हम लोग. दिस इज योर IM, दिस इज IC, दिस इज I0, राइट? तो I2 इधर है तो I2 R2 किधर होगा? I2 R2 इसके पैरेलल होगा. I2 R2 जो वाइंडिंग का ट्रांसफार्मर सेकेंडरी वाइंडिंग का रेजिस्टेंस है दैट इज R2. So there will be a drop in that winding resistance due to the flow of current I2. So that drop is basically your I2 R2, right? And then again you will have to add JI2 X2. So again it will be leading in nature. तो इसके 90 डिग्री पे लेना पड़ेगा. इसका 90 डिग्री कुछ इधर होगा, so this will be your E2, right? ये एंगल 90 डिग्री and this is your JI2 X2, ठीक है। नाउ I2 इस डायरेक्शन में है, तो इसके जस्ट अपोजिट डायरेक्शन में होगा I1 डैश्ड, this will be your I1 डैश्ड, this is IC, and the phasor summation of this two current I1 dash and I naught will give you I1, ठीक। अब यहाँ पे I1 R1 होगा I1 के पैरेलल, this is your I1 R1, and perpendicular to this will be J I1 X1, and the resultant, oh sorry, इसको ठीक से ड्रॉ करना, and the resultant value will be V1. So from this phasor diagram, you can write the two equations. V2 is equal to E2 plus I2 R2 plus JX2. Similarly, here you can write V1 is equal to E1 or V1 dash plus I1 R1 plus JX1, right? And you can represent the various angles. Suppose this is theta1, this we have already mentioned theta2, and between V1 and I naught is suppose theta naught, right? So this is the phasor diagram of the transformer at लीडिंग पावर फैक्टर लोड। अब अगर यहाँ I2 इस डायरेक्शन में एज्यूम करोगे, यहाँ पे इन बिटवीन V2 एंड D2, तो ये फर्स्ट एक्सिस में फर्स्ट क्वाड्रेंट में आएगा I1 डैश, so you will have to take the resultant of I naught and I1 dash, and in the same way you can draw the phasor diagram. अब तीसरा मैं तुम लोगों के ऊपर छोड़ता हूँ, which is actually the ideal condition. Phasor diagram at unity power factor load, ये खुद से ट्राई करो। यूनिटी पावर फैक्टर में होगा क्या कि इन दैट केस V2 जो कंसीडर हम लोग कर रहे हैं इस डायरेक्शन में, जो V2 ले रहे हैं, V2 के सेम फेज में होगा I2, there will be no phase difference between the secondary current I2 and the terminal voltage V2. So accordingly you have to take the various drops. तो इसी डायरेक्शन में तुम्हारा हो जाएगा I2 R2, फिर इसके परपेंडिकुलर में होगा JI2 X2. तो you can draw the phasor diagram at unity power factor load also, right? ये समझ में आ गया phasor diagram सबको क्या होता है? बताओ, आगे बढ़े, नहीं तो कुछ डिस्कस करना है तो बताओ। हेलो, हेलो, आई थिंक कुछ नेटवर्क में इशू है, आवाज नहीं आ रही है।
हाँ सर, अब आ रही है
यस
सर
सर,
आवाज।
आ रही है।
यस सर, आ रही।
अरे तो
सर
इतना
बीच
तुम
में
लोग
नहीं आ रही थी।
क्यों रिस्पॉन्स इतना स्लो क्यों? किस प्रोसेसर में चले गए हो तुम लोग? हाँ ना, कुछ जवाब दिया करो, ऐसे तो पता ही नहीं चलता नेटवर्क है या नहीं है, या कहानी चल रहा है कुछ। चलो ठीक है, ओके। So at last, today we will discuss about the equivalent circuit of transformer. Right. So we have already drawn the equivalent circuit diagram uh, for an ideal transformer, right? So here now we have to show the effect of the winding resistance, that is the component for the winding resistance as well as the leakage reactance. ठीक है, तो इसमें पहले बनाओ सर्किट, वाइंडिंग का रेजिस्टेंस है तो रेजिस्टेंस रिप्रेजेंट किए, लीकेज रिएक्टेंस को रिप्रेजेंट किए, देन यू हैव द टू कॉइल्स, ट्रांसफार्मर सिंबल जिससे हम लोग रिप्रेजेंट करते हैं. Similarly for the secondary circuit, draw the representation. There will be resistance, winding resistance, then leakage reactance, then you have load. There is magnetic coupling between the both windings of the transformer. So here you have the supply voltage V1, this is R1, this is X1, this is R2, X2. The voltage across these two terminals, output terminals, we have considered it as V2 in the phasor diagram. E1 is the induced EMF, E2 is the induced EMF across the secondary coil having N2 number of turns, and here this is your V1 dash is equal to minus E. ठीक है, induced EMF across this coil is right, but V1 dash we have considered such that it will oppose it, तो उसका डायरेक्शन चेंज होगा इसलिए माइनस ई ले रहे हैं. This is your I2 current, this is your I1 current, right? And here we have represented the core component of the transformer. In the previous class we have already discussed that the no load current is flowing through the core part, which is responsible for the development of flux. This Im is responsible for the development of flux, and the loss in the transformer is represented by resistance, क्योंकि resistor में ही जो है loss होता है. So this is the core loss component current, core loss current, which is a component of no load current, and this is your I1 dash, right? So this is the equivalent circuit diagram of transformer, right? Here we have considered the terminal A B. क्या consider किए थे? A B C D, A B C and D, right? So this one is your equivalent circuit representation of single phase transformer. Now for simplicity we can transfer the parameters of either side to the अदर साइड, मतलब देखेंगे हम लोग अगले क्लास में कि देयर इज ए पॉसिबिलिटी टू ट्रांसफर दिस R2 X2 in the primary circuit of the transformer, and vice versa is also possible. The different parameters, circuit parameters in the primary circuit can also be transferred to the secondary circuit. Now it depends upon the number of turns N1 and N2. तो ट्रांसफॉर्मेशन रेशियो को चेंज करके, एडजस्ट करके वी कैन ट्रांसफर द पैरामीटर्स इन ऑर्डर टू सिंप्लीफाई दिस सर्किट फॉर मेकिंग द कैलकुलेशन पार्ट इजी. उसका सिर्फ सिग्निफिकेंस यही है कि कैलकुलेशन को इजी करने के लिए किया जाता है. फॉर एग्जांपल यू कैन कंसीडर इफ N1 is equal to N2, that is both the turns means turns in the both the coils are equal, then E1 will be equal to E2 because U is equal to N1 by N2. ये हम लोगों ने derive किया था, right? So if this is the condition, then these 2 points A and C can be directly connected, and B and D can be directly connected with each other, right? Without disturbing the circuit conditions. But However, if E1 and E2 are unequal in magnitude due to the difference in the turn on the respective side, then the secondary circuit quantities should be converted to the primary voltage levels before it is transferred to the primary circuit, and vice versa. तो वो जो भी है ट्रांसफॉर्मेशन, that is approximate equivalent circuit of transformer, ये हम लोग नेक्स्ट क्लास में देखेंगे। ठीक, सो आज के लिए बस इतना ही है। किसी को कुछ पूछना हो तो पूछ सकते हो, otherwise we can end this session. If you have any question, doubt, you can ask.